So first, I just want to make sure that you guys can see my screen here. So everyone can see that okay?
Yeah, we see it great, thanks.
Okay, good. So this is this application right here. It's kind of a combination of our basic viewer with more of our advanced functionality. The basic viewer that you see here is on these two tabs here, the address search and feature search. But I'll touch a little bit on the PIN operations and the network navigator as well. And so, yeah, this is running on a Internet Explorer browser. It runs on any functional browser, Firefox, Safari, Chrome. And yeah, so you have the map on one side. It's basic. You pan around. You can pan around with your mouse. It's reading the information directly from an Oracle database, so there's no middleware there. You have this tool here to kind of pan around.
So when you when you say an Oracle database, that lives here and connect up with the Esri database?
The configuration can be done either as a cloud implementation, like some of our smaller utilities might do.
Okay.
So we could put the Oracle Spatial Database behind a web server and essentially serve it up to you and just link to your data. We might even be able to show you an example. We took another utility in Colorado and took one of their feeders and fed it into the Oracle Spatial Database. And so that's just the way that we're doing the geospatial rendering here. If you chose to have the Oracle Spatial there, or if you already had it there, then you could just as easily put it inside your four walls.
Now, if we have it here, is that an embedded Oracle license, or would we have to buy the Enterprise Oracle?
It's basically, it's not the Enterprise Oracle. All it is the Oracle Spatial with the locator function. And so it's not a very expensive license. So I don't think you should be too afraid of that.
Okay. What cloud services have you used before?
This is being run off of a server at AGSI's offices right now.
Okay.
Okay, and
so it's really a host.
It could be any data center could be the host for this.
Okay.
Yeah, this is hosted for demo purposes at our offices here in Toronto, but our client hosts their own data on site there. We do that for some clients. We host data for other clients. It all depends on what you want to do.
Okay, so you haven't done anything with like the Amazon cloud or anything like that yet. It's just been a hosted cloud service.
Yes. Yeah. Okay. So yeah, it's pretty intuitive. You can zoom in using a scroll bar. You can zoom in using this. So sorry, the scroll on the mouse, and you can see that there's scale-dependent layers. So these are the secondaries that don't turn on until we're at a certain level. You can also manually control that. So if you still didn't want to see the secondary conductors and the meter banks, you can turn those off if you didn't want to see those or if they're cluttering up your screen. We have a overview map, so you can kind of click and drag the map around. One up there. So that's kind of the basic navigation tools there. All the information you can hover over and just kind of see the information on this transformer or this meter here. This meter is on site at our client. Will have all the information, name, phone number, everything that's important to them. But obviously for demo purposes and security purposes, we don't have that information. But it is linked to their CIS. So this meter here would have the name and address and the service type that they have as well. You could also just click on the feature and it'll populate on the side. This works for any feature. So click on the transformer bank or a switch and it populates on the side there. You can search by address. If you have your address information stored somewhere, we can access that through a web service. For this client, AGSI also maintains road networks and address points for most of Canada, but it probably wouldn't work out there in Washington. But if we want to search by address, I'm just going by what I see on the screen there. They'll search for all the addresses there. We can map it, centers on that address. And we could also do by intersection. So if you know the nearest intersection, you can just map directly to there. And then you can search by feature as well. So if I want to search for, let's say, solid blade switches that are on a certain feeder, you can search by virtually any attribute that you have in the table. So there's 3 solid blade switches on this feeder. The results show up down here, and you can export those results to Excel actually. So you can run your own custom queries using this tool. Pick any one you want, any attribute you want, and then it saves in here. So you can make reports on the fly, send them off. And then you can select one of them.
Well, you can attach the report to an email message or things like that.
Yeah, yeah. So yeah, you can select one. The attributes will show up here. You can ask to map to it. And so there is that switch. You can see it's an open one. That's the symbol they use for a normal open point. This little target symbol right here is just kind of directing your eye to it. You can get rid of that. So there's that switch. One thing I forgot to show you a little bit earlier, you can add in imagery. Burlington Hydro, this client here, has their own aerial photography that they paid for that we don't exactly have access to, but we have a Digital Globe web service that we can call. So this is just calling Digital Globe. It's reprojected on the fly because Burlington has all their data in UTM, and the web service comes in lat long, but Oracle will reproject on the fly. So that takes a little bit longer to do it that way if it's on, so we'll just leave the base map on. We also integrated some Google Street View, so if you wanted to see what that switch looked like, it'll call up Google, and there is the open switch right there. In case, well, this application is more or less used in the control room, Burlington Hydro, so if they want to see what they're dealing with, they can bring up the Street View. We have some reports. On top of making your own report using the search engine here, you can pre-pop or make up some queries in our configuration engine, pre-packaged, so you can very quickly, run what switches are on this feeder. It populates here. And this is kind of a nice, easy to see table within the browser. And again, you can export it into Excel. There it is there. So for this application here, like I said, it's mainly just for viewing purposes. We have done work for other companies where they've needed to not only view their data, but update or add data where necessary. So as Paul was mentioning a little bit earlier, we did some work for La Plata out in Colorado. So this is the application we built for them. They have different grid sections that they need to be able to search by. So if we pick one of these grids, search for it, it'll map to the center of that grid. So they do one grid at a time, so they need that functionality in there. They bring up the attributes of this pole. As you can see, they don't have a lot of attributes at all, so they can begin to fill in some of the information while they're in the field. And this is linked right to a GPS. So if you're out in a truck, you turn on your GPS and it'll center the map to where you are. We can insert pictures or documents. A little picture of a pole right here. So now this picture is linked, and if I were to update this pole, so now that's successfully updated this data. We have the picture of the pole here. And that's done on the fly in the field, and everybody in the office can see that right away. So
I think we also learned, I guess Nick learned a couple of weeks ago, is that using the iPad is that you can directly link it without even pulling it all the way through back to the database because of the way the caching is done and stuff.
yeah, exactly. So yeah, using an iPad, you don't have to actually store the image on your device. It will just get sent directly to the server. So it kind of avoids some redundancies. On a Windows tablet, you would have to take a picture and then add it after the fact. But yeah. So we also have a disconnected mode here. So one of the main things that La Plata wanted, being in the middle of the Rockies and having spotty internet connectivity, was a way to view their data while they're offline. So this is, sorry.
Hang on a sec.
Can we interrupt? Yeah, before we get on to that piece, can we go back to the quick conversation about the iPad and the ability for the photos and stuff? Is that because there's an iPad app or an iPhone app versus just hitting the website through Chrome?
My understanding is it's part of the core functionality of the iPad and the way they're caching is that it's going to directly link that photo and upload it back to the server. And there's really no application out on the device. In fact, none of the stuff you're seeing here has any application functionality on the devices whatsoever. You're really relying on the browser itself and the HTML5 in terms of how it caches on the individual mobile device.
Okay, you're already on HTML5.
Yes.
Got it. Thank you.
Sure.
No problem. So yeah, going back to this is just it's storing the information on the device so that if you get disconnected from internet connectivity, you're able to actually still access your data, update your data, add pictures while you're disconnected from the internet. And when you have connectivity again, you can go in and upload all the changes, and then any of the changes you made while you're disconnected will get applied. So yeah, if you are someone like La Plata in the middle of the Rockies where you're not going to have great connectivity, it's a good thing to have so that you can still have your data, update your data while not physically being connected to the network.
So does
sorry, go ahead.
Does that screen on the left there where it changed based to an input, does that change automatically based off of your network connection?
No. No, currently you would store this. If you knew you were going out to an area, you would store it in advance. Because if you lose connectivity, like when you're storing this on your device, you need internet connectivity to do all the downloading. So if you lose connectivity, there's no way for it to download automatically. But normally what they would do is they would store a pre-cache an area before they go out. And if they realize they have no connectivity, they'll switch to this. So.
Okay, so it's a manual process then to cache it. It's not something where if you're driving along and all of a sudden it drops connection, it'll just maintain it.
Right. Yeah. Currently, it would be manual.
Yeah. So basically, what it would happen, like in the case of a Durango, they've got a particular circuit. This happens to be their P121. And they've had historical bad connectivity issues in this area. And so what they were envisioning is they could take this feeder and essentially cache it on the mobile device and then drive out of connected range and do what they wanted to do and then do their updates and then come back and have that stuff all upload once you get back into connectivity. And
so for our terrain here, we kind of go in and out as you drive a road quite sporadically, and it's not. There are some sections that are consistent. There are other sections where it depends on cloud cover or rain or just in general the time of the year. It's not. It does for how strong our cellular connectivity is.
Yeah, and you're going to need that connectivity to get either updates from what's changed, or to actually access and download the data and cache it. So it's one of those things where if you know you've got an area that's intermittent, then what you would probably do is select an area, select the number of tiles or a certain map area that you want to preserve, and you'd go ahead and select what data that you want to cache. So you'd say, well, give me all the poles, give me the transformers, give me the lines, give me, whatever it is that you think you're going to be working with in an area that's got sporadic coverage. Well, you would just cache that and just go ahead and work in disconnected mode instead of waiting for it to go in and out. And then when you know you've got connectivity, then turn the connectivity back on, do your updates, do your changes, and then move on, go back into disconnected mode and keep going.
So how much data can it cache at once? Is there a limit?
We haven't seen the limit yet, okay? We've got some fairly large utilities. We haven't really seen the limits yet. That's one of the things that the guys in Durango were going to help us do, is this is a fairly large area for them, and so we wanted to see if we could just capture and save the whole thing out there, and they're still playing around with it. We've got a couple of things they've asked us to do. One of them is, if you look on the left-hand side here, this edit box, they wanted the ability to dock that down to just like a tab or something, and so we should be able to do that for them. It gives you a much more viewing area on the screen. So that's one of the changes they've already asked for in this, but they haven't seen the limits yet either, and neither have we, so we don't really know where that upper bound is. It kind of has to do with the device itself, because if you got a 16 gig iPad, you may be doing better than if you got a 4 gig.
Sure.
Okay.
Yep, thank you.
Okay. So that's kind of just the basic map viewer functionality. I looked over the requirements document that you had handed to Paul. So there are a couple things that I could still show you that I saw there was linking to AMI data, customer counts, tagging, truck locations. So I'll just show you a few things that we have for that. A little background, we stored some AMI information from the night that Hurricane Sandy rolled through this area. So we got some outages throughout that night, and I can look for it here. So we have information on, well, Burlington here has a smart meter on every single customer, so they get real-time readings and outage flags, and we're able to capture some of that for some time periods during Hurricane Sandy. So these gray ones that are gray area that you see here are meters that reported out. I think this is about 3 in the morning on the night that Sandy rolled through. So you can see here, with the exception of this meter, which seems to fail to report, it looks as though this fuse here blew. You can select the fuse here, and if we go into Network Navigator, you want to see what meter banks you have downstream, trace that. Now it highlights downstream of this fuse. That's using their connectivity model. So again, if you have a connectivity model, we could work with you to get the kind of same results we have here. And then down here is a list of the meter banks. Again, at Burlington, they have the names and numbers of these people. We can only just have the network ID for showing, just for security purposes. But yeah, you can get customer count. So just regarding this first switch, there are 11 customers reporting out from this. We can also show schematic tree diagrams of that exact same network. So this is just a kind of a logical connectivity model of it, or we can still do some downstream, upstream tracing. So downstream of that fuse are these 5 customers. And again, there'll be names and numbers. And then it actually shows up in the geographic as well. So you can see in 2 places the trace, along with some upstream trace as well if I want to see what's upstream of this meter. It actually goes all the way up to the breaker. So that's our tracing. We have pinning and tagging as well. So if there's a crew out and they have to fix this fuse, they can place a hold off on it. So if we want to add a hold off to this pin, we'll just say it's a storm rush or switch storm restoration. And post it. It's going to do a search for nearby devices. F76, we'll post that. Now everybody can see that there's been a hold-off tag placed on this pin. Who created it? The requester. We have truck locations. They have a kind of a fight going on with the union over whether or not to put the GPS on the trucks, but we have the technology to kind of track where these trucks are through GPS, so you can see which truck is closest to this work. We've linked to their asset inspection application to show where there's work that needs to be done. So this hard hat here is showing their work needs to be done at this transformer, and this truck's already there working on it. So if you see this truck's here, it's the closest one to this tag. It's the one that could go out and repair that. And then we also link to SCADA. So one of their stations there. Let's find the breaker.
So when you say that you link to SCADA, how do you typically do that?
So they have the main SCADA database, and that's actually located one town over, but they have a replication server where they get the current status of each device, and we just kind of read directly from that. So if a breaker that's normally closed is suddenly open, then we can pin that by reading that that data server.
Do you know how you're doing that? Like what kind of SCADA system they have, what kind of database? Is it a multi-speak? Is it a DNP? Is it a direct database read? Like, how are you actually doing that?
I'm not sure myself, to be honest. They're using surveillance.
Okay. That answers the question.
Sorry?
That answers enough of my questions right there.
Okay, yeah. And so this got automatically tagged when the recloser was blocked on this breaker here. So, yeah. So, yeah, that's. I hope I covered everything that was on that list there. I don't know if there are any questions.
It's basically a web messaging interface to the data sources that you want it to link to. So think of it almost like a hyperlinking to wherever data sources you want, because this is really designed as a real-time networking, network monitoring, network management kind of technology behind this. And that networking technology all runs on the same Oracle spatial database. And so you really got one place that all this data is being served to this viewer. And you would configure the certain views that each group or each user would have individually. So, you know, if you've got people working in member services and they're going to know, you know, what bill history, payment histories that this customer got, or they want to know this, then those would be data that you would access just from perhaps your CIS or wherever you designate that data to come from. So I'd ask Nick to try to kind of cover as many of the things that were listed in your requirements list. Is there some things that maybe you're thinking about or needing or wanting that we didn't address? Or
well,
I saw that you do wildcard searches.
Yeah.
When you're searching for things, can it search multiple different feature classes for the same item?
So,
well, the way the data is stored is in a data model in Oracle Spatial Database, and all these things are related to one another. And so, essentially, any data field within the database is a searchable, queryable field. And so, it gives you a lot of flexibility in terms of how you want to search for stuff.
Okay. We need to search for a facility number, and we want to return anything that's in polls, anything in the database that has that facility number, and it can be multiple things at one point.
Be multiple features.
Multiple features.
oh, okay. So, like, if you wanted to search a wildcard for any device that maybe the ID starts with F, regardless of what feature class it is?
Exactly.
Yeah. I can't see why not. I'm sure we could do some views on that. I honestly, we haven't encountered that request before, but because most of the time they want to search, polls where it starts with P. So yeah, using Oracle kind of makes things open for us to create views that we can unite, your transformers, your poles, your meters together into one view. So yeah, it's something that could be done. I don't have anything I could show you right now, but it's something that
like
could
in
be
the
done.
Esri database structure, you've got this feature class notion where you've got polls in an area of a feature class, but the way this database is structured is it's a much deeper. In other words, it doesn't kind of think about things in separated feature class layers and laying them over one another. What it does is it drives all of that data throughout all the richness of and depth of features that exist at a point, and it makes them all searchable against anything else. And so it doesn't actually work with feature classes the same way like an ArcGIS does.
Okay.
So in your feature search, Nick, when you're doing a feature search, it seems to me, if I recall, don't you get like a long list of things that pop up when you start looking for? There was like a drop-down list of all the things that are on this section, line section. I mean, you can do a polygon, for instance, and return all of the results for different kinds of features that are within that area.
Yeah, we could do. This is kind of an older application that we're transitioning right now, so I didn't really want to show it too in depth. But we do have a field, so I can search by polygon and capture all the poles, pattern transformers, pole transformers, conductors that are within this polygon, and that'll bring up a access database of all of the different. Now, there weren't too many things here, but the conductors and poles that were within that. So that's kind of a fence search that we can do. But as for a wildcard search, that's something like I said, it's something with Oracle and view creations can be done. It's just I have nothing I can show you to prove that, but it's something that can be done. So.
And the general idea is this basically very flexible in that we've got users that are using this basic browser or intelligent Mapbook kind of an interface and doing lots of different stuff. I mean, some of them are using it for doing some analytics things, like they've got a transformer overloading analysis app with some dashboards and some other stuff they're using at Toronto Hydro, for instance. They're doing some heat mapping stuff with the guys at Burlington are doing, and so it's pretty flexible in that we just haven't had anybody that has an application running that's asked for a wildcard search per se. So the implementations look a little different, but the core database and the searchability of any feature or item within the database field is completely configurable.
Okay. talked about the offline viewer. Going back to the picture thing that you guys were showing, does that link? We keep our pictures as a hyperlink in the feature in the database. So it's a hyperlink to a one-line drawing. It's a hyperlink to a picture, and it's just an attribute field in the database. Is that when you say that it sends the picture to the server, or you can view it from your app? Where is that picture living? And can you marry that picture viewer up with what we already use?
Yes, we can. Basically, what's going on in the background is we'll have a table that's kind of a lookup table where it looks up the feature to a file path location. So the picture itself is getting sent right back to the server and being stored in a folder. And then what happens on the database side is, that poll will be linked to this file path. And then, so that when you click on this poll where I add the picture, it'll bring up the reference to this picture, this little thumbnail here, and then it adds it here.
So you're essentially using a file. You're essentially using a file path name, which could be a file path to a location or a folder within a server that you've dedicated for this. But in the same sense, it could also be used as a file path to a URL to access a web service, like you did with the digital globe imagery.
So is that file path controlled by your software, or can I dictate the file path name and everything? So say I want a folder for each poll, and it's the folder's name, the poll ID.
That's purely that's a configuration issue for you in your instance. So you get to decide.
Okay.
Much the same as you were seeing that with Burlington, for instance. They're not going to a file path for a digital globe web service. They're going to a file path with their imagery folder located on a server in-house.
Okay.
And the same would be true with like a PDF. If you've got PDFs stored that are scans of as-built, then you could link to that and bring that right in. So it's not necessary for you to move all this data from wherever it is to some central database here. You can essentially hyperlink using the file path method for accessing anything, whether it's a web service or a dedicated server or a file folder location somewhere within your infrastructure. Which is the same concept as you see that would happen with accessing the data from SCADA, or if you have a database where you're storing meter information. The same basic concept holds in each case.
Okay. I think we are good on our in what we want to see. Can I follow up with you later?
Oh, absolutely, absolutely. In fact, I told Nick that we didn't want to take you guys off into some gory details here because we have some stuff that you guys will probably find very interesting, even when it comes to some of the smart grid projects and pilots you guys are doing. You might see some applicability there, but we just really wanted to kind of contain ourselves here a little bit. We knew you were really looking for a basic viewer or a browser, and we think our intelligent map book kind of is a good fit for that. But, there are other things we could do later. We can certainly talk more about other things later, too. But I wanted to kind of try to focus as best we could,
Well, thank you very much.
Oh, thank you.
Great. Well, I appreciate it, folks. And, Sarah, I guess I'll talk to you here offline shortly.
Yeah, that sounds great.
All right. Thanks a bunch, folks.
Bye.
Bye.
Bye.